Section 10.3, we're going to continue talking about conic sections with the ellipse. I'm going to talk more about all of this information in a couple slides, but for now I would pause the video and write all this down. For now, here's the general equation for an ellipse: x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1, where the center is h comma k. The right side of the equation is always a 1 for an ellipse, and there's always a plus in the middle for an ellipse. A squared and b squared might switch places. A squared we always call the biggest number, so the larger denominator. So the a might be under the y or it might be under the x. Depending on whatever number is the biggest, that's the one we label as a. C is the distance from the center of the ellipse to each of the foci. And there's a relationship between a and b and c. C squared equals a squared minus b squared. So there's a plus in the general equation for an ellipse and a minus in the c equation. So here's a diagram of an ellipse. You have a major axis, which sometimes is horizontal, sometimes is vertical, but it's the longest chord. The two major vertices, the two foci, and the center all lie on that major axis. The distance from the center to a major vertex, so half the length of the major axis, we call that distance A. This smaller chord, perpendicular to the major axis that goes through the center, is the minor axis. We have two minor vertices and the center on that line. Half the distance of the minor axis, so the center to a minor vertex, we call that distance B. The distance from the center to a foci, or a focus, we call that distance C, and they're equidistant apart. And we have that relationship that c squared is equal to a squared minus b squared to relate a, b, and c. The definition of an ellipse: if you have a point anywhere on the ellipse, then if you connect that point to a focus, those are called focal radii. There's two focal radii. The sum of those focal radii for any point on the ellipse are the same value. In fact, it's the length of the major axis. It's 2 times a. So the sum r1 plus r2 is 2a no matter where you are on the ellipse. So if I have another point up here in a different place on the ellipse and it has two focal radii, then those two focal radii are equivalent to r1 plus r2, which is equivalent to the length of the major axis. So here we have the equation of an ellipse in standard form. So the first thing we want to do is put the equation of the ellipse in center form, which means we're going to need to be able to complete the square. So go ahead and pause the video and complete the square in two variables to be able to put this in center form. So the x squared, there is no linear term of x, so that's actually already completed the square. We don't need to worry about x squared. We always factor out the leading coefficient on a squared term, so I factored out the 3. So I had 3 times the quantity y squared minus, I factored out a 3 out of the 12y and got negative 4y plus leave your space equals, I moved the 9 over, equals negative 9 plus leave your space. Divide by 2 and square, you add a 4 here, but we didn't really add a 4, we really added 3 times 4, so we need to add a 12 to the other side. So unlike circles that we would leave it in this form, in ellipses we always need this side to be equal to 1. So we're always going to divide by whatever that constant term is, so I'm going to divide every single thing by 3. So I divided every single thing by 3. I leave this 1 in the denominator just because that's kind of the standard form of an equation of an ellipse. So now I can read off the center of the ellipse. Remember, it's x minus h quantity squared plus y minus k quantity squared. So my center is 0, 2. I'm also going to read off my a and b values. So remember, a squared is the bigger denominator. So in this case, a squared is going to be 3. So a is going to be the square root of 3. B squared is the smaller denominator. So b squared is going to be 1. So b is going to be a 1. So this tells you how far to go in each of those directions to find the vertices. So in the x direction, I want to go the square root of 3 in both directions. So in the x direction, I'm going to go the square root of 3. The square root of 3 is about 1.7. So I went 1 and a little bit and 1 and a little bit. So those are my two vertices, my two major axis vertices. So I can write down those two vertices. I went plus root 3 and I'm still at a y value of 2, so I have root 3 comma 2. And I went negative root 3 and I'm still at a y value of 2, so I have negative root 3 comma 2. Now my b tells me how much to go in the y direction because b is underneath y, so I want to go 1 in the y direction both directions. So I'm going to go up 1 from the center, and that's going to be a minor axis vertex. And I'm going to go down 1 from the center, so that's going to be a minor axis vertex. So my two minor axis vertices are 0, 1, and 0, 3. So the last part is I need to find out where my foci are. So I need to find my c value. Remember that c squared is equal to a squared minus b squared. So c squared is equal to 3 minus 1, which is 2, which means c is the square root of 2. So that tells me I'm going to go the square root of 2 along my major axis, so in this case the x direction, and those are going to be my foci. So I'm going to go root 2 in my major axis direction, which is in the x direction in this case. So I went plus root 2 from my origin, or from my center, and minus root 2 from my center. So my two foci are negative root 2, 2, and positive root 2, 2. So this is a pretty small ellipse, but this is the ellipse of this equation. So now we have another one. Again, same thing. It starts off in standard form. You want to find the center, the foci, and the vertices of this ellipse. So go ahead and pause the video and do the same thing we did on the previous example. So to complete the square, factor out the leading coefficient from x squared. So factor out the 4. You get x squared plus 2x plus leave your space. Plus factor out the leading coefficient of your y squared. So factor out your 3. Y squared minus 2y plus leave your space equals 5 plus leave 2 spaces. Divide by 2 and square it is a 1, but you really added a 4, so add a 4 to the right side. Divide by 2 and square it is a 1, but you really added a 3, so make sure you add a 3 on that side. So you end up with 4x plus 1 quantity squared plus 3y minus 1 quantity squared equals 12, but this side has to equal 1, so we divide every single thing by 12. So you end up with x plus 1 quantity squared over 3 plus y minus 1 quantity squared over 4 is equal to 1. So if you read your center off of this, you end up with a center of negative 1, 1. So now, what is your a value? So remember, your a value, a squared, is always the bigger denominator. So in this case, a squared is your 4. So a is going to be a 2. And b squared is your smaller, so b squared is 3. So that's going to be a root 3. So if you haven't finished this already, go ahead and pause the video and find the vertices and the foci. So a squared is always the bigger value, so 4 is going to be a squared, which means a is equal to 2. B squared is the smaller value, so that's going to be b is equal to 3. So that means I'm going to go 2 in the y direction because a was underneath y. So I went up 2 and got negative 1, 3. And then I went down 2 and got negative 1, 1. Then I'm going to go root 3 in the x direction because 3 was underneath x. So I'm going to go root 3 in the positive x direction, so that's going to be negative 1 plus root 3. And then I'm going to go negative root 3 the other way, so I'm going to get negative 1 minus root 3. So those are my 4 vertices. I found c squared. C squared is equal to a squared minus b squared, which is equal to 4 minus 3, which is equal to 1, which means c is equal to 1. I'm going to go in the y direction because they have to lie on the major axis, and the vertical is my major axis in this case. So I'm going to go up 1, and I'm going to get negative 1, 2, and I'm going to go down 1 from the center and get negative 1, 0. So biggest thing, always make sure a is your bigger value, a squared is your bigger value. Always make sure you go in the direction of whatever the number is underneath, whatever variable it's underneath. And then make sure your foci are in line with your major axis. Now for this one, we want to find the equation of the ellipse, given that the center is at 0, 0, one of the foci is at 3, 0, and one of the vertices is at 5, 0. So I've plotted that. I have my center, my focus, and my vertex. I've also started an equation, x minus h quantity squared over something plus y minus k quantity squared over something is equal to 1. Now I just want to decide, okay, is a going to be under x or is a going to be under y? Because my foci is in line with my x, I know that my major axis is going to be along this x-axis, so I know that my a squared is going to be underneath x, and my b squared is going to be underneath y. So you have the distance between the center and a focus, you have the distance between the center and a major vertex. So go ahead and pause the video and try to write this equation and finish out this graph. So I know that ellipses are symmetric, so that means that if my center is at the origin and one of my foci is 3 away, then the other foci has to be 3 the other direction at negative 3, 0. If one of my major vertices is at 5, 0, then the other one has to be at negative 5, 0. That means that my distance A from the center to a major vertex is 5, and since that's in the x direction, a squared, which is 25, is going to go underneath x squared. H and K are both 0 because my center is at 0, 0. I know my distance C, which is the distance from the center to a focus, is 3. So I use C squared equals A squared minus B squared to find that B squared is equal to 16. So I could plug that into my equation. And then also that means that B is 4. So for my minor axis, I'm going to go up and down 4 to find my minor vertices. So this one is just working backwards. Instead of starting with your equation and finding everything out of it, you're starting with the information and building your equation out of it. So now we're going to have a word problem. I would pause the video and write this down first. So here I have my drawing. Whenever you see this term, a whispering gallery, that means it's an ellipse. So whispering galleries, the ceilings make the shape of an ellipse. So I have an ellipse here. I kind of drew it on a coordinate plane with the center at the origin. Jim's at one focus, 6 feet from a wall. 100 feet away from him is his friend. If Jim's 6 feet from his wall, then his friend must be 6 feet from his wall because everything is symmetric. So knowing this, what's the length of the whispering gallery? Well, they're both 6 feet from a wall, and they're 100 feet from each other, so it must be 112 feet long. Now we want to find the height of the whispering gallery at its center, so we want to find the height here. Well, we know that A is the distance from the center to a major vertex. In this case, our major vertex lies on our floor, so the center to a wall. And we know that C is the distance from the center to a vertex, so we can fill in these values. Go ahead and pause the video and fill in A and C you know, and use that to help you find B, or the height at the center of this gallery. So the distance from the center to the wall, or the half the length of the major axis A, is 56 feet. The distance from the center to a focus is 50 feet, or C. So C squared equals A squared minus B squared. You end up with B squared is 636, or B, the height of the ceiling, is 25.219 feet. So when you have one of these word problems, set it up just like you would on a coordinate axis and start filling in the pieces that you know. All the same ratios and relationships apply.